Okay. This is what we call the design flow. So what you will go through when you want to design your circuit from the design conception, or what we call the specification, and the next one is the design entry. So normally we have two type of design entry. The first one is we call the schematic capture, and the second one is to use the language or HDL. In our case, we use Verilog, all right, and we don't use the schematic also. And synthesis now here is done by computer, right? You write your code here, and this one is the computer job to generate the circuit, the netlist for you. We call it synthesis. So synthesis is simply translate your language to the netlist, to the circuit, all right? And when you have the netlist, you can see the functionality of your circuit already by using what we call the functional simulation. All right. So here we can see whether, at least in terms of functionality, for example, when you design a multiplexer, so you can see whether your design is correct or not by using functional simulation. All right. So in this case, we will use waveform. For example, if you have multiplexer, so you have three input, right? So you give the input to that three input port and see the output, whether it is correct based on the multiplexer specification or not, right? So if not correct, for example, you expect the output to be 1, and suddenly you have the output, you get your output 0, right, instead of 1. So means that something went wrong in your design. So you need to go back to edit your code, or redesign your code, all right, and do the synthesis again until you have the correct simulation, at least in terms uh, of functionality. But still, you still have many steps to go before you can configure to the chip, to the FPGA chip. All right. So now you need to do physical design. Here means that we map to the correct device. So if you look at devices, FPGA devices in the market, there are many devices, thousands of devices available there. So you need to choose which one is, or which one you want to use. All right. So when you select the one that you want to use, you need to do what we call the timing simulation, because the the speed of the FPGA is different from FPGA 1 to the FPGA 2, from one device to another device, right? So you need to make sure that your design meet the timing simulation. For example, if your FPGA is slow, means that your design cannot be faster than your FPGA. If not, it will not function. All right. Although your functional simulation here is correct, but if it is met the not meet the timing requirement, then the end result will be wrong also. All right. So you need to make sure that the timing is fulfilled. Yeah. So if not fulfilled, again, you need to go back and look at your design, whether what is wrong with your design, and how to improve it. Yeah. All right. So that is how. So if everything is passed here, all right, then you can do the chip configuration. Chip configuration means that you program to the real hardware, real FPGA, right? Now come to the Verilog modeling style. So how many modeling style that we have that is available? All right. So there are three modeling styles that are available. Yeah. The first one we call data flow modeling. All right. So data flow modeling is actually by using continuous state assignment statement. So means that if you have the Boolean equation and you use assign keyword, all right. For example, this, you use assign keyword, assign y0 equal to not x1. So this is not x1 and x0 and enable. All right, is y0 and y1 is this, y2 is this, y3 is this. So it means that you use data flow modeling. Data flow modeling. All right. So remember, if you use keyword assign or you write your code to generate your circuit, to model your circuit using using continuous assignment like this, means that you use data flow modeling. All right. The next one is the behavioral modeling. So behavioral modeling is when you use or when you describe your circuit using sequential assignment. All right, or sometimes we call it procedural assignment. Sequential assignment, and very easy, means that if you use uh, always block like this, and if this equal to this, else this equal to this means that you use behavioral modeling. All right, behavioral modeling is that when you want to design your circuit, but you don't have equation, for example. All right. So for example, you want to design a circuit which is big. You have 10 input, for example. This is quite difficult to generate or to get the Boolean equation, right? If you have 10 input. So maybe the best way is to describe your circuit using behavior. All right, the circuit behavior means that if I have this kind of input, when I put in the circuit, I should have the output like this. That we call behavior. All right. So for example, if x0 equal to 0 and y0 equal to 0, z should be equal to 0. Else, z equal to 1. So this is behavior of the circuit. All right. So when you do this, means that you model your circuit using behavioral modeling. All right, as simple as that. And the last one is the structural modeling. So what is structural modeling? Just like the name, structural means that you define your circuit using the structure of the circuit itself. For example, you instantiate the gate. Gate instantiation means that you define your circuit based on the structure of the circuit itself. All right. You have the schematic, for example. The schematic is the structure of your circuit. So when you use AND, instantiate AND gate, instantiate OR gate like this, right? Means that you use structural modeling, all right? Or you instantiate the module, all right? That also means structural modeling, all right? So very easy to differentiate between the three. So in our class, in our course later on, we will always use these three types of modeling. All right. First is data flow. Second one is behavioral modeling. The last one is the structural modeling. Always important. All right. All of these are important, equally important. All right. So it depend on the on the nature of your circuit. So sometimes it is good to model your circuit in data flow modeling. Sometimes it is good to model your circuit using behavioral modeling. Sometimes it is good to model your circuit using structural modeling, and sometimes maybe you combine behavioral and structural, or you combine all the modeling style in one design. Right? So it depends. Okay. Oh, finish? Yes, finish already. Or chapter 1. All right, now we have done with chapter 1. Now I want to show you how to use Quartus, the software. So this is my screen. So when you install the Quartus, so you will have this. So this is the version that I recommend to you. All right, 13.0 SP1 service pack 1, and this is the latest one. I have also 20.1. All right, so we can install both or only this one. And actually the functionality, the interface is almost the same, except that the latest one support more optimization features and also support the latest FPGA devices. But the problem is, if you have this one, it will not support the FPGA devices that is the old devices, less than I think 5 more than 5 years old. All right. For example, the one that we have, the hardware that we have here, the DE2 board, donated by Intel also. The latest one is not support the older FPGA board already, FPGA device already. So the one that is support the FPGA that we have is this version 13.0. That's why I asked you to install 13.0, because later when you want to do project, master project using FPGA, so that you can use this one. If not, you cannot use, cannot implement in your hardware. All right, so that's why I ask you to download and install this one. So in this case, let's see. I will show you how to use this one. Right? Okay. So go back, and I try to. Now what did you see? Okay, so I try to launch the Quartus 2 and see what is the interface. Okay, can you see the screen? Can you see this? Yeah, yeah. For those who cannot see, please click on in Google Meet. Uh, on the list of the participant, click on uh, my face, my tab. All right, so that you can see this. So this is the when you first launch the software. So this is the interface of your software. So for example, we want to design a very simple circuit. Let's say we want to design what let's choose the what is the circuit that we want to design. Maybe we want to design this one. Maybe the half adder here. So we have the half adder, and the design is very simple. So let's say we design this. Yeah. So to start your design, you need to go to File. So for those you who have the software already installed already, so you can follow this, or if you don't have, you can refer back to the video. I record the lecture, so I will post on YouTube so that you can go to the YouTube and follow the instruction here. All right. So first you need to go to File, yeah, and the best way is to use New Project Wizard here. All right, just click this so that you will have this window, introduction and so on. So just click next here, and here is the directory or folder of your top level entity. Means that your module, you want to save your module in which place, the location of your module in your hard disk. So in this case, I have this. Maybe I have a folder for this. All right, and I have a very specific folder for this design. Maybe I name it half adder HA. This is my folder. So the file, the design file will be inside this folder. So I click select here, and the name of the project is HA also, or you can use any other name. All right, click next and add file. So in this time, at the moment, we don't have any file to attach to our design. Later, if you have your design, which is a big design that you want to include another module in your design, maybe you need to attach the file. But this at this time, no need to attach the file. So just skip this step, click next. And here is the device, the device that you want to use. Means that the actual FPGA, the hardware that you want to implement or download your design to. All right, in this case, the one that we have, yeah, in our university is the Cyclone 2. So if you use the latest version of the Quartus, this Cyclone 2 is not available. All right. So for this version, yes, we have Cyclone 2, and Cyclone 2 is the device family. Means that in that family, you have many more devices like this. If you look at here, you have many other devices. So you need to choose the correct one. So in our case, the correct one, you need to uh, filter the list a little bit so that it is easier for you to search. So in this case, our device should be 672 pin count. Means that the number of pin for this FPGA device is 672. Speed is, should be the fastest one, and the first one is the device. The first one should be the device that we have. EP2 C35F672 C6. So this is the device that we have. So just select this and click next. Or if you want to see the functionality of your design, maybe you can skip this step, or if you use the latest version of Quartus 2, so you may skip this step. Let the software to choose the device for you automatically. But of course, you cannot implement in the hardware, because to implement in the hardware, you need to select the correct device. But if you want to see the functionality of your design, then any device should be okay, right? So in this case, I choose the correct one. Click next. Tool settings, just uh, next, proceed. No need to do any setting. All right. Simulation, maybe we can set later on. All right. We can set here also, but in this time we set later on when we want to do the simulation. So click next. All right. This is the summary of your setting. So just click finish. When you click finish, you can see that, okay, here is your device name. All right, and this is your design name, HA. All right, so this is based on what you type before this, in the setting before this. All right, so now we want to write our code to describe this uh, half at a second. So just go to the file new, or just click this button. All right, click, and you will be shown to or bring to this window, pop-up window. So you have many type of design file that you can use. For example, schematic, or VHDL. In our case, we use Verilog HDL. So select this, just click OK. Then you will have the text editor that you can write your code already. Alright, so to write your code, so you need to start with module. Okay, the name of your module is HA, and the port list, right? So the port list, so based on our design, which is this one. All right, so you have A, B, and sum and carry. So these are our port list. All right, so it should be A, B, sum, carry, and this in this case, the name of the design is half adder. In this case, we use HA only, so it should be no problem. So we have A, we have B, we have sum, we have carry, right? That are the port. And here you have input, all right? Because A and B are the input, and sum and carry are the output. So you have input A, output B, right? Input A and B. So the signal is 1 bit. When you have later on, if your size of the signal is bigger, for example 2 bit or more, so there is a way to describe this. We can see later in the next chapter. All right, in this case the signal is only 1 bit, so you have output, sum and carry. Right, straightforward. And you describe using in this case using data flow modeling, because we use the assign assign statement here, assign keyword here. All right, so this will be data flow modeling, and sum is equal to A XOR B. Sum is A XOR B, and carry is A and B. Right, very straightforward. So we use the assign keyword. Assign sum is A XOR B, XOR B, and assign carry is A and B. Right, that's it. So we have done. So it should be end module. Okay, so this is our design already, and we want to do this. All right, after we have design, what to do? This is what we need to do: synthesis. After we design here, we do the synthesis. So synthesis means that we instruct the computer. We want the computer to produce the circuit for us. So you can synthesis. Okay, you can do the synthesis by go to processing. Processing. In this case, you can choose this one, start analysis and synthesis, or in this case start. Yes, you go to start and select start analysis and synthesis. So but in short you can use this button. So normally I use this button. Very hard to find from here. So use this button, start, the shortcut is start analysis to synthesis. Click this. You need to save the design. So you need to save the design first. So in this case, you save as HA and make sure that is the same as your module name. You save, and the computer will do the synthesis for you. and make sure that there is no error. If there is error, so you will have the error list here. All right, in this you have one warning, and when you check the warning here is about the license. So because this is a free version of the software, so one of the feature which is parallel compilation is not licensed, so it is disabled. So this is about license, but this is not a problem. We can still use this, only that compilation is done in not done in parallel, means that it's a little bit slower as compared to the licensed version. All right, because in licensed version you can do this parallelly. All right. uh, so it's good, but if you have other warning, you need to check what is the warning, because sometimes in terms of syntax, in terms of typo here, there is no error, but maybe sometimes the connection is not that correct. Sometimes your pin is floating, for example, or your pin is stuck at ground or stuck at VDD, also stuck at the same value all the time. So maybe this is wrong. This is wrong. So you need to check, right? So if it give you some warning, then that in this case only one warning, and the warning is about the license, and should be no problem. All right. So now you can see uh, the your design by using the netlist viewer. So you can go to tools, netlist viewer, RTL viewer. So here you can actually see your design. All right, so the computer will generate this design for you automatically based on the library that they have. uh, so some is from this, and you can do the functional simulation, means that you want to simulate, when you give the series of input, and you can see the output whether it is correct or not. All right, so we can do that using the simulation. So how to do simulation? So there will be two type of simulation. I mean two methods of simulation. One is by using a waveform, all right, to describe the input and to see the output. Another one is you write a script to define the input and output. All right, that we call the test bench. All right, and it is used in the industry. So when you go to the industry, the simulation is done by using a test bench. So in this course, I will teach you how to do both. So for simple design, we can use actually the waveform simulation, but for the more complicated design, we need to use a test bench to to simulate our design. So in this case, I will show you by using uh, a waveform editor. So you can go to here and click new and go to the University program. All right, University program, and click OK. All right, and you will bring to the new window. This is a waveform window where you can insert your signal here and run the simulation and see the output in the format, in the waveform format. All right, but before that, before you do that, you need to do some settings. All right, make sure that the setting is correct. So please make sure that you have this in your setting. So you go to tools, go to option. All right, and you will have this window, okay, and choose EDA tools option. All right, so EDA tools, and make sure that the model sim here, all right, the directory or the folder of the required file is set like this. Okay, so where is this file? So you need to go to your Quartus 2 installation file. So in this case, I installed in my C drive. So in Altera, and this is the folder, and you need to go to model sim ASE and select this one Win32 ALOEM. All right, and just select folder, and here is the, the folder that you need to set, yeah, in your model sim, yeah. And if that is okay, the path is correct, then you just click OK. That is the first setting that you need to do. And the second one is you need to go to assignment, click setting. All right, and this is the window, and you need to have the tools name, and select the model sim Altera and click OK. All right, and now you can edit your design. I mean the waveform, the simulation waveform. So you have the empty waveform window like this. So first thing is you need to insert the list of port in this uh, window. So how to do that? You can double click here, so that you will have this pop-up window, and you can type the name of your port. But the best way is to use Node Finder here. Click Node Finder, and it will bring to this window, and you just click list, and will list all the available port that you want to monitor here. So you can select one by one, or you just click all like this, so it will bring all the signal that, or the port that are available in your design, right? So here we want to see A, B, and carry and sum, right? So you just click OK there, and OK again, and you see in your simulation window you have all the port already. And here in the waveform, you can edit. By default, it is logic 0 all the time. All right, logic 0, and carry is don't care. We don't know yet what is the output here, because we haven't started the simulation. So to edit, you can select the duration, the range of the signal. For example, this is from around this is 80, right? So around 50 nanosecond to 100 nanosecond. So if you want this time the signal A to be high, so this is how, right? And here you want the signal B to be high, so you can use this. Or you want to change, for example, from here to here you want to be 0, you can use that. Or you can use any other uh, uh, signal level. For example, you want to forcing don't care here, high impedance here also can. So it depends. So the easiest way to get the all the combination is by using clock, a series of pulse wave. For example, if I use clock here for A, I select on this, and I use clock. So the period, uh, for example, 500 nanosecond. So I can see, yeah, my signal is from 0 to 250 nanosecond, it is low, and from 250 to 500 nanosecond, it is high, and repeat again. All right, so this signal is quite accurate, from 0 to 250, and so on. So in this case, let's, for example, I change, this is quite big, so let me change to 500 to big, so let's 400 maybe, okay, smaller. And the second one, maybe I change to 800, so that 800, so that I can have the waveform like this. Yeah? See, for example, from 0 to 200 nano, yeah, A and B are 0, 0, 0. And the next one, the next 200 nanosecond is 0, 1. And this is 1, 0, and this is 1, 1. So all the combination of A and B are uh, uh, given here, right? So we can see if 0, 0, input 0, 0, what is the output here? Carry, for carry, and for sum, for example, if 0, 1, what is the output here? All right, so let's try to simulate this. You need to save your waveform, and please don't change the file name, yeah, because the setting is to use waveform, the default. So just leave it as default, waveform. Save, and then how to simulate? You go to simulate, and you run functional simulation and timing simulation. Not yet, yeah. So in this time, timing functional simulation, or you can use this button, run functional simulation. So click run. So it will try to do this. Okay, invoke the model simulator, and will give you the output. Yeah. So here is the output. So let's see if 0, 0. So the output should be 0, 0, right? Plus, 0 plus 0 is 0 for sum. And 0 plus 1, sum equal to 1, and 0 carry equal to 0. Yes, exactly, this is correct. So 0 plus 1 still the same, correct? And 1 plus 1, so you have carry equal to 1, and sum equal to 0. So this is correct. All right. So this is how we simulate our design using Quartus tool. All right. So if there is no question, so we will stop here. Thank you very much.